With AWS, they have access to the same, services for HPC at the same scale that these customers operate, regardless of their compliance or classification requirements. So there's nothing limiting them in terms of the technology they can use at whatever compliance or classification requirement they're working at.
So HPC, high performance computing, refers to cases where you're using a lot of computers because you've got big, complex simulations and you need to use thousands of nodes. Sometimes you need high performance storage. Sometimes you need low latency network interconnects. Sometimes you need all three. And the challenge is that some of your on-prem data centers, some of them are huge, but a lot of them aren't. And so they end up with capacity and availability constraints on their resources, and that leads to long queues. And what that really means is that engineers and scientists' productivity gets slowed down. They've got to wait their turn. They can only use the resources that are allocated to them. Kind of that general slowdown doesn't leave them a lot of room to modify their experimental plan once their simulations have been launched. When you adopt the cloud for your HPC, that can help your engineers be able to focus more of their time on solving their problems rather than figuring out how to procure and manage their computing resources.
A lot of these problems are computationally difficult and you can't solve them on a single computer. So you need big, large numbers of computers to make it tractable inside like a human lifetime. Government is full of examples like that. But like in our own world, like Amazon Prime Air, when those guys were designing those drones, those things are going to be delivering books into your backyard soon, and hopefully pizza as well. Really, really, this is one of those cases where time is money. They ran all of these simulations on AWS, so they could actually scale them to thousands and thousands of cores and get all these simulations done in, they could do in hours what used to take weeks. If you can speed up the design phase of that, it means you can get that, you can get those things airborne sooner. And at a government level, when you're talking about what happens at the federal government level, everybody benefits from that stuff.
I've got another example. This is a company called Maxar. So Maxar is, among other things, kind of a satellite intelligence company. So they used to run on-prem, and they migrated to HPC services at AWS to deliver their weather forecasts 58% faster than NOAA's weather supercomputer. So what happens there is NOAA releases data, and then they generate a forecast. And Maxar's play was to be able to beat NOAA's forecast. Their customers could take action on that forecast sooner, and that was something that their customers were willing to pay for. So tangibly, the weather predictions that they used to require 100 minutes to complete, they were able to get that time down using AWS to 42 minutes or less. And that's substantially faster than their previous benchmark. And it was also substantially faster than NOAA's forecast production time.
But now there's a lot of companies like that are using AWS for HPC, but it still seems like government is in the early stages of getting into this stuff, right? Commercial companies have adopted the cloud much faster for HPC. Why do we think the government groups are having a harder time of it?
Yeah, I think it's a combination of things. One, government's just generally more risk averse. And even if that tech has been completely vetted, there's this stigma that, some government customers just think maybe they don't have access to that tech because they don't think it aligns with a certain compliance regime or requirement that they have to align with. And sometimes that just prevents their use of the service. Just that misunderstanding there, I'd say, is something that can block them. And the last thing is sometimes government customers just, they think their capacity requirements are too much. They're just fearful that all this work that they've put into this on-prem capacity is not, something that could be supportable, long-term at scale in another environment. With AWS, they have access to the same, services for HPC that you guys always talk about at the same scale that these customers operate, regardless of their compliance or classification requirements. So there's nothing limiting them in terms of technology in AWS, and there's nothing limiting them in terms of, the technology they can use at whatever compliance or classification requirement they're working at. I know AWS is working very hard to ensure that the services we have are available and accredited, at whatever compliance regimes our government customers are aligning with. And then that, again, they're available across all regions that our government customers are using.
Few years. I think there's maybe one other factor missing, which is that a lot of government customers don't necessarily immediately see intangible dollars because they don't measure a lot of their outcomes in dollars. They don't necessarily see in tangible terms the dollar result that comes from an increase in productivity inside their organizations. If a drug company can get a drug to market 6 months sooner, that's worth billions of dollars to them. And they see that on their bottom line because they see it on the top line. It's difficult for a government to do that because governments don't measure a lot of outcomes in terms of billions of dollars. They measure costs in dollars. They don't measure the outcomes in dollars. They measure it in lives saved, emergencies averted, those sorts of things. And so it's worth, I guess, reminding our government customers that there are really big benefits. And maybe it's a good idea to see if they can try and quantify some of them.
Yeah, the government procurement cycles make just the whole concept of paying as you go a little bit difficult. We've got numerous contract vehicles in place to allow these types of customers, to access mechanisms that give them, the ability to acquire AWS resources. And there's a bunch of publicly available pricing calculators that we use, and people like me on the field teams can help customers with, when actually filling those out to project what their costs might be. But then there's also the concept of reserved instances and savings plans, which is slightly different than the on-demand model, where you're committing to a certain amount of utilization up front. You can decide to pay all up front or partial up front or no up front, and you get a significant discount. But that gives government customers a way to, if they need to allocate money or obligate money, they can do that. But also,
it's just a full disclosure. I used to work for a government customer, but I didn't really understand this. I was a relatively small user, and I didn't understand that there was a way to drive my cloud expenditure lower, besides just using less. So we all kind of know that industry partners, they have a huge role in providing new capabilities to the government.
Yeah, well, thankfully, a lot of these companies that, traditional, defense systems integrator, the DIB, like all these companies that do work on behalf of the federal government, a lot of them are already part of the AWS partner network, the APN. Some software vendors like ISVs, like Siemens that Booth mentioned earlier, like they're already in the marketplace. They're already part of the AWS partner network. So from a software licensing perspective, it makes it easier for government customers to acquire. Some have migration competencies, others have different other competencies that they align with, which is cool because these are huge companies. These private companies are huge companies, and while they might have just a small component of that company working a government contract, they have another component of the company that is super specialized in AWS that they can always bring in to help with these types of workloads. A lot of the companies and integrators they're already working with already have the capabilities and the expertise to do a lot of the stuff that we've talked about today, and that we're gonna talk about moving forward here with HPC workloads in the cloud.
In some of our past videos, we've discussed the core services that folks use to run their HPC workloads. So we're going to dive deeper into some of those services now that are relevant to government customers in particular. If you're enjoying these videos, please give us a like and consider subscribing to the channel so that we can keep making more to help you understand how the cloud works and to show you new ways to help all the scientists and engineers around you who use HPC every day to do amazing things. It's what gets us motivated as well. See you next time.